Good day, viewers. You are welcome to another edition of our mathematics class. In our previous lesson, we started with the topic simultaneous equation. We said that when two linear equations are solved together at once, it is called a simultaneous equation. That is when it has two variables. So in our last lesson, we looked at how to solve simultaneous equation using a substitution method. So today, we want to look at how to solve a simultaneous equation using elimination method. Remember last lesson I told you that we can solve mathematics using substitution method, elimination method, or even graphical method. So today we are looking at the elimination method. Now, in elimination method, you can use elimination method to solve simultaneous equation when none of the variable has 1 as a coefficient. Remember last time I told you that substitution method is best used when one of the variable has 1 as a coefficient. But in this case, with either 1 or not, you can still use the elimination method. So I say that this method is very useful to solve simultaneous equations, especially when none of the coefficients of the unknown is 1. In elimination method, that is most especially the one that none of them is 1, you may need to multiply one or both of the equation by a number in order to obtain a variable with the same coefficient in both equations. Then add both equations when the signs of the variables you want to eliminate are opposite, but subtract them when the signs are the same. So, in this case, when you want to solve something like this, you need to make the coefficient be the same so that you'll be able to eliminate. And how do we eliminate it? Either by addition or subtraction. So you now decide the variable you want to eliminate. So if you want to eliminate a particular variable, you now look at the sign. If the signs are the same, you subtract. If the signs are different, you add. So let's take example. Example. Use elimination method to solve the following simultaneous equations. The first one, 6x plus 5y is equals to 15. And the other equation is 3x plus 5y is equals to 12. So we're going to take them one at a time. Plus 5y is equals to 15. Then we have 3x plus 5y is equals to 12. Now from this equation that we have, you discover that one variable, they have the same coefficient which you can easily eliminate without multiplying anything. So as usual, I say you name it equation 1, and the second equation you name it equation 2. So since y have the same coefficient, and what is the coefficient? 5. So we can easily eliminate y so that we can find x. So how do we eliminate y? Remember I told you that if the signs are the same, you subtract. So this is the variable we want to eliminate. And look at the sign plus plus, which means they are the same. So we subtract. You either say subtract equation 1 from equation 2 or subtract equation 2 from equation 1. So in this case, let's say subtract equation 2 from equation 1. So this is what we have. So we just go straight to subtract. 6x plus 5y is equals to 15. 3x plus 5y is equals to 12. I say subtract equation 2 from 1. So this is what we have. 6x minus 3x will give you 3x. Then 5y minus 5y is what? 0. Then equals to 15 minus 12 is what? is 3. So now we have only one variable. So we have 3x is equals to 3. We are looking for x, so we divide both sides by 3. So 3 can cancel 3, then our x will be equals to 3 divided by 3 here is 1. So we've gotten the value of x to be 1, but we need to get the value of y. So you can now substitute x equals to 1 in any of the equation of your choice. So I will use 1, you can now use the other one to try. So let's say substitute for x equals to 1 in equation 1. You can try equation 2. So wherever we see x, we write 1. So we have 6 into 1 plus 5y is equals to 15. 6 times 1 is 6 plus 5y is equals to 15. So we are going to subtract 6 from both sides to clear this 6 here. So let's say subtract 6 from both sides. So we have 6 minus 6 plus 5y is equals to 15 minus 6. So 6 minus 6 is 0. So I'm left with 5y is equals to 15 minus 6 is what? 15 minus 6 is what? Is 9. So you're looking for y, you divide through by 5. So my y is equals to 9 over 5, which is an improper fraction, or so we now change it to mixed fraction to be what? 1 whole number 4 over 5, or you can still write it in decimal as 1.8. That is in decimal. So that is it. Remember here, we normally say collect like terms, which is still the same thing as subtracting 6 from both sides. Okay, let's look at the second example. We have 3a plus 2b is equals to 21. 5a minus 3b is equals to 16. Now looking at this one, none of the variables has the same coefficient. So we need to make one of the coefficients to be the same, either by multiplying with a number based from my introduction. So we need to make one, either A or B, to be the same. So which one do you want us to eliminate now? Okay, let's eliminate B. Now we want to, guys, if we want to eliminate B, we make 2 and 3. The coefficient here is 2, the coefficient here is 3. So we need to make their coefficient to be the same. Okay, so now let's multiply. In this case, we say what? Multiply equation 1 by a particular number. I think their LCM here will be 6. So we multiply equation 1 by 3 and equation 2 by 2 to make them the same. So this is what I'm trying to say. Equation 1, we multiply it by 3. So if you multiply this by 3, this is what we get. 3 times 3 here will give us 9a plus 3 times 2 here will give us 6b is equals to 3 times 21 here will give us 63. Then equation 2, we multiply by 2. 2 times 5 here will give us 10a plus, okay, it's minus 2 times 3b here will give us 6b is equals to 2 times 16 will give us 32. So this is what we have. Now you see we have B. The equation of B are now the same, which you can easily eliminate. And again, I told you that, okay, look at it. Check out the sign. The sign here are different. So therefore, we are going to add the two equations. So if you so wish, you can continue and say this is equation 3 and this is equation 4. So since the signs are different, we're going to add these two equations. So we say add equation 3 and 4. So let's add them now. 9a plus 10a, it will give us 19a. 6a plus minus 6b will give you 0. Plus minus 0 equals to, let's add this one. 63 plus 32 will give us 95. So our equation now is 19a is equals to 95. We are looking for a, so we need to divide both sides by 19. Divide both sides by 19. So 19 will cancel 19. So now we need to eliminate this one too. A is alright, 95 divided by 19 is what? Of course, if you do your calculation well, you should get 5 as your answer. Alright, now we've gotten one of the variables, remaining one, which is B. So you need to substitute A is equals to 5 in any of the equation. Now let's use equation 2. You can also check it out in equation 1. So let's use equation 2 now. We have 5 into, our A is also 5 minus 3B is equals to 16. So 5 times 5 will give you 25 minus 3B is equals to 16. So you can collect your like terms. Let me use collection of like terms here. Or we can say subtract 25 from both sides. But then let's collect like terms. So we have 25, let me take this one here, minus 16 is equals to 3b. I decided to take minus 3b to the right hand side to clear the negative number. Alright, now 25 minus 16 is 9, which is equals to 3b. You're looking for b. So we divide both sides by 3. 3 cancel, so our b is equals to 3 divided by 9 divided by 3 is 3. So this is what we have. Therefore, we conclude that our a is equals to what? 5 and b is equals to 3. So this is how we use the elimination method, most especially if the variables